All right, here we are for honors physics. Homework is projectiles, worksheet 2. Taking a look at problem number 3. It says, in the 1970 Soccer World Cup, the famous soccer player Pele kicked the soccer ball past the goalie to score the first goal of the game, enabling Brazil to win 3-2 against Romania. If Pele kicked the ball with a velocity of 18 meters per second, 13 degrees above horizontal, so that's this angle here, then determine the horizontal and vertical velocities of Pele's soccer ball. So, can I draw a soccer ball? Probably not. Yeah, I know that it's like a combination of like pentagons and hexagons, I think. I think the patches on a soccer ball. So I'm just going to do this and not sweat it too much. Already putting more time and effort into this than I really need. Wow, that looks awful. Okay. Well, anyway, it's a soccer ball. Okay. And you say, all right, we're going to kick that so that it has a velocity of 18 meters per second, 13 degrees above horizontal. It's going to look something like this. Here's my velocity vector. 18 meters per second, and 13 degrees. So we want to find the components. We want to find the horizontal and vertical velocities. Those are the components. When I have a vector and I split it up into pieces like this, those pieces along perpendicular axes, those are called the components, the parts. So I'm going to just go horizontal, vertical. We know the angle between horizontal and vertical is always a 90 degree. And that means it's a right triangle, and we can use right triangle trig. We can use sine, cosine, and tangent to find the sides. So this side here, the horizontal velocity, this is going to be adjacent to the 13 degrees. So it's the leg of the triangle that's touching the angle. So it's the adjacent side. And the 18 is the hypotenuse, the longest side of that right triangle. So I know that the cosine of an angle is equal to the adjacent over the hypotenuse. I'm trying to solve for the adjacent side here, that horizontal velocity. So I'm just going to get this adjacent side by itself. So I need to move hypotenuse to the side. I'm going to multiply both sides by hypotenuse. So hypotenuse times the cosine of the angle is going to equal the adjacent side. I'm putting the values that I know here. The hypotenuse is 18 meters per second, and the angle is 13 degrees. I can punch that in my calculator. 18 cosine of 13. And my calculator tells me that that is 17.54 meters per second. I know it's in meters per second because that 18 was in meters per second. I'm splitting this velocity into other velocities, so same units. Okay, what about the vertical component? You say, well, the vertical component, that's this side of the triangle. That's the leg that's not touching the angle. That's the opposite leg then. And the hypotenuse I know is 18. So opposite and hypotenuse, reaching back my memory, I know that that is the expression for sine of an angle is equal to the opposite leg over the hypotenuse of the triangle. I'm trying to solve for this opposite side here. So I want to move hypotenuse over to the other side by multiplying both sides by hypotenuse. So we'll have hypotenuse times the sine of the angle will equal that opposite side. Put our values in. 18 times the sine of 13 degrees. Punch that in my calculator. And I get 4.05 meters per second. That is my vertical component. I might label the horizontal component V subscript X, or maybe my V naught subscript X, because it's my starting velocity for this thing as it goes into the air. And this might be my V naught subscript Y, my starting vertical velocity. All right, and that is problem 3.